Hello, this video is going to talk about inscribed angles in a circle. What are they? How do we deal with them? That kind of thing. And let's get started. To make an inscribed angle, here's what I'm going to do. I'm going to pick a point on the circle. I'm going to ignore the standard point that comes with it. I'm making my own. And you can use any point. From that point, you need to draw two chords. So I'm going to put one of them over here, and I'm going to put one of them over here. They don't have to be evenly spaced or anything. It almost looks like I made a right angle there. I didn't mean to. As a matter of fact, I'm going to drag that one a little bit so it doesn't look like it. Two chords coming from the same point, you have an inscribed angle. And it's easy to recognize an inscribed angle because when I look at this angle right here that I've made, its vertex is going to be on the circle because we used that point to make the angle. That's where both of the sides of the angle came from. Now, I said chords before. If these are extended and they go outside the circle, it's fine. We can still focus on that part inside the circle where that inscribed angle is happening. What we need to know about the measure of an inscribed angle, it's not like a central angle. Remember, central angles were the same as their intercepted arcs. An inscribed angle is always going to be half of the arc that it creates, half of its intercepted arc. So whatever the angle is, you can double it to get the arc, or whatever the arc is, you can take half to get the angle. And so that's the relationship that we note for these angles. Go back a couple steps. Whoops, that's not what I meant. I just erased my angle. Oh my goodness. Let me try this again. Let me put my circle back on here and recreate my angle, which is awfully easy to do. I'll go to right there. Why not? We can certainly move these points, and you'll notice as I'm moving these, the arc that's right there between these 2 points, that's kind of inside the angle, is changing size. But you'll notice down here that the angle is also changing. So they're keeping up with each other and maintaining that relationship that the angle is always half of the arc. So next thing I want to do is talk about a very special case. This is our last topic for this. If I do, I'm trying to line it up here. Let me make sure I'm doing a good job. I'm putting that in so that I have a diameter to use because the special case involves that. When one of my chords goes to one end of the diameter and my other chord goes to the other end of the diameter. If you think about this situation and know that the angle is always half of the arc that it intercepts, since this is a diameter, this arc is 180 degrees. So I guarantee you that this angle is 90 because the angle is half of the arc. And that's true no matter where this point goes. My circle's a little bit big. Let me pull that in a little bit, get it on screen. No matter where this point goes, this angle here is always going to be 90 degrees. And so that's kind of a special case, but sometimes they'll give you a picture like this, and they don't mark that as a 90-degree angle because they expect you to know that it's a 90-degree angle. So always watch for that. If this goes to one end of the diameter and the other one goes to the other end of the diameter, notice that your arc is 180, so your angle is 90. But in general, without the diameter, the angle is always half of the intercepted arc.